Okay, so we're going to do a quick review here. We're going to focus on 4 lessons that we went through yesterday, 6.1, 2, 3, and 4. The very first thing we're going to talk about is what a vector is. So a vector is something that must have 2 requirements. Anyone know what they are? Magnitude and direction. Okay, so we must have, I'm going to type it since it looks much nicer when it's typed. We must have magnitude and direction. Okay? So, we need to have both of these in order for something to be a vector. So, a good real-world example would be something like an airplane. I'm a great artist. And if an airplane is traveling at 500 kilometers an hour, that would be considered what? A scalar, yes. What part of these 2 requirements would this fulfill? Yeah, that would give us the magnitude of the plane. If I just left it at that, we're not a vector right now, okay? Because we don't have any direction. We know the plane is traveling 500 kilometers an hour, but we have no idea which way it's going, okay? Direction is very important. If I now say it's traveling 500 kilometers an hour and a north 60 degrees northeast, okay? This is now a direction. This direction is saying that it is 60 degrees north in an easterly fashion. So what that means is if we have a compass, oh, it'd be nicer if that arrow pointed the other way. There we go. So here's our north. Okay, we're looking at something that is 60 degrees in the east direction of north. Okay, so this would be a rough estimate of what direction the plane is flying. What if I just said that a boat is traveling east? Does that fulfill vector? Yes, no, maybe so. No, why not? Have no magnitude. We have no idea what speed or how far it's going. Magnitude could be a number of things, but it needs to be some value. Okay? So that gives us a quick idea of what a vector is. When we describe vectors, let's roll this down. Okay? There's a couple different ways we can mathematically represent them. We're going to just call this AB. Okay. So in this case, this could be shown as vector AB. We know that. What's another way I can represent this vector? Ah, very good. This could be negative BA. Why negative BA? Opposite of an opposite. Good. So vector BA would be going the other direction. We're traveling from B to A, opposite direction of this. If I put a negative sign up, it flips that direction. It puts us right back to where we are. So that's actually, we can represent that as negative BA. We can also use, we can decide to represent it maybe just as a lowercase letter. We'll call it just vector V, okay? So there's many different ways we symbolize a vector. I think that was mostly the first lesson. That's a quick overview of 6.1. Let's go to the next page. Okay, 6.2, we talked about adding and subtracting vectors. Okay, when we're adding vectors, let's give ourselves a title actually. Okay. So let's say we have 2 vectors. In this case, I'm going to change it a little. Change the names. We're going to call this vector x and vector y. Okay. And maybe the question asks us to add vector x to vector y. We learned 2 different ways to do it. What I'm going to focus on is just moving one of the vectors. So, let's say it says vector x plus vector y. The way we were shown yesterday is kind of follow it as a story. Since vector x was the first one, we decided to take that route first. So we start at the tail ends of both, and we move to the end of vector x. Okay? From there, I need to now go to vector y. But vector y is all the way, let's get that. Vector y is all the way down here, and we're standing over here. So what I'm going to do is I'm going to move or superimpose an image of vector y to the end of vector x. So we move an image of it over here. There we go. So that is the same distance and direction as vector y. It's parallel to it. And we've just moved it over so we get an idea of where we would be moving next. So then we decide to follow the route of vector y. We come all the way to here. So we need to make a resultant vector of x plus y. So what vector would represent x plus y? And what we mean by that, let's get this here, that's vector y, is we had started all the way back here and we ended here. So our resultant vector is a straight line from the starting point to our ending point. Okay? So we'll change the color even of this one. This vector, or this, would be considered our resultant vector. Now, in the book, it can be represented many different ways. In fact, I can represent this vector as a combination of the two other vectors. This red vector here can be called x plus y. A lot of times they'll give it another name. Maybe they'll call it vector z. Okay? But don't get confused if in the book they decide to not give it a single lowercase letter to represent it. They might use two letters to represent it, or two different vectors, okay? Which is completely fine. Just try to keep track of what they're talking about. So this red vector, let's pretend we didn't even give it a z, and it's represented as vector x plus vector y. If we were to subtract vectors, we'll use the exact same two. We'll scroll down a little. Let's say the question changed a little, and we're looking for vector y, subtract vector x. Okay, and we're looking for the resultant vector. Let's take these two that we have here. Oops, that's not what I wanted. That's what I wanted. Go. And we're going to take our other vector y. So these are our originals, x and y. Now what's important is, again, like I said before, we're going to try to follow the story. In this one, it says that we want to essentially go across y first. Now it technically doesn't matter which one we go through first. We're going to learn that, or we did technically yesterday, a little later in the day. But it doesn't really matter. We're going to end up at the exact same point. So we go across y. And then from there it says we need to subtract x. Or in other words, we need a version of x going the opposite direction. The negative sign gives us an opposite direction of the vector. So I'm going to make a copy of this one. And instead of going here like we had done before, and if you notice, just a quick side note, that whether I went across y and then up x after, this resultant vector would have been the exact same. Doesn't matter which route I would have took. But in this one, we're looking for negative x. Okay? So this would be considered x. Negative x will be going the other direction, down this way. So I'm just going to take the magnitude of this. Can I actually flip it? I might be able to. No, that's not what I wanted. Instead, I'm just going to drag it down, make life easier. So our negative x would be like putting the tail end the other way. And this would be considered negative x for a vector. It's going in the opposite direction. So now our resultant vector is different from before. We started here, and we ended over here. I should have highlighted that we did go across negative x. So we went across here, down to our new resultant vector. And that resultant vector, again, can be represented as just vector y minus vector x. Okay. So this is a quick recap of 6.1 and 6.2. All done in 9 minutes.